Okay, girls, we're going to go through this next section. We're on chapter 6, section 1. And I told you to go ahead and read through here, but I'll go ahead and give you your definitions. It would be helpful if you did read through the section. So we're going to find all of these values of data that is falling underneath these normal curves. And so we're going to use that table in the back of the book to do so. So let's go through our vocab first, and then we'll go in through some practice problems. So we're looking at the normal distributions. So remember what the normal distribution looked like? It was that normal curve. So it was that bell curve, and our mean was right there in the middle. Okay, so that's what we're going to focus on. So symmetric distribution is just when the data values are evenly distributed among about the mean. Negatively skewed is when the majority of the data values fall to the right of the mean. I'm going to go through this quickly. You can always just pause it to fill it in. And these are right in your book. I pulled these right from your book. Positively skewed is when the majority of the data falls to the left of the mean. Normal distribution is just a continuous, symmetric, bell-shaped distribution of a variable. Standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. That's what we're focusing on now. Our z-value is the number of standard deviations that a particular x value is away from the mean. So your z-value is just the number of standard deviations that a particular x value is away from the mean. And then I just wrote down here that table E and that appendix C gives you the area under the curve for any z-value. That's what we're going to focus on, is that table E. Okay, so then on the next page of your notes, I ask you to go ahead and draw the figure 6-2 graph in your notes, and it's on page 299. And so I did that as well. And your first figure is of a normal curve. So this line here is your mean, median, and mode, and that's just your normal distribution. Then the next example was the negatively skewed. So here's your different mean, medians, and mode, and it's negatively skewed. So remember, you go back to your definition of negatively skewed, it means that the majority of the data values fall to the right of the mean. So here's your mean, and then most of your data is over here. Positively skewed, your mean, median, and mode, and now you're going to see that most of your data falls to the, if you look back at your notes, positively skewed says that the majority of your data falls to the left of the mean. Here's your mean, and everything, almost everything is falling to the left of that, and that's positively skewed. Okay, so make sure that you're able to recognize those and go back and forth with those from the definitions to the diagrams. Next one is your procedure table. This was on page 303. So there's three different versions of how you're going to find the area under your curve, and this is very nice because it tells you exactly what to do. So if you're given an example that's you need to find the area under the curve to the left of any z-value, you're going to look up your z-value and then use that area given. So anything to the left of your z-value given, you're just going to look up into your table, and then that's going to be your area. And these are examples of how your diagram might look. So here's your mean, that's 0. Remember, that's the definition of normal distribution. Our standard is that our mean is 0. And then our z-value is over here. It's positive. So anything positive would be on this side, anything negative would be on this side, just like our number line. So a positive z is over here, and we want all of the area to the left of that. And then here's another example. If our z was negative, it would be over here to the left of our mean and all of the area under that. That's just how we would draw it out. To find the area under the curve, you just use that table, you grab the number. I'm going to show you. We're going to go through the table. Okay, so now how about if we want to find the area under the curve to the right of the z-value? So we went to the left up here, now we're going to go to the right. So if I have a negative z-value and I want everything up here, I'm going to look for that data value, but then I'm going to subtract it from 1, because to the left is the data value. So I need everything that's not included to the left. So I need to take 1 and then subtract the z-value, and then that would be my area under the curve. And that's a diagram of what it would look like here. If the z is negative and then if the z is positive. You just need to remember these steps. And then how about if I'm interested in the area between two different z values? And that's what the diagrams here would look like. So if I have a negative z, positive z, and I'm interested in the area right here. Or how about if I have two positives, the area right here? Or if I would have two negatives, the area right here. You're going to have to find those two z values and then subtract them. That's all. So nothing too terrible there. So let's go ahead and try a couple and see how we do. So for our first example, we have, we need to find the area under the curve to the left of z equaling 2.06. So I have it right here on the top of your page. Go to Appendix C, find Table E. So I have that marked, and I'm here. So I'm going to go ahead and just put this right on top of my table. And the first thing I always do is I draw my figure, just so that I can be comfortable with what I'm looking at. So to the left of z equals 2.06, I draw my normal curve. Positive 2.06 is going to be somewhere over here, and to the left of it, so I draw my area in. So now the next thing is I go to my table. So I need to find z equaling 2.06. So I go right to this table here. 2.0 is right here. And now I need to find 6 because it's 2.06. So 06 is over here. I go down and across and I get 0.9803. That's the area under the curve. So then I write down my answers. Z at 2.06 is 0.9803. I need to write that as a percent. I move the decimal over twice and I get 98.03. Sorry if you couldn't see that. Okay, so nothing too terrible there. So now the next example is to the right of z. Now remember, to the right, that was the next procedure step. Now we have to subtract it from 1 because our table here is going to tell us everything to the left. So I'm interested in to the right of z equaling negative 1.9. My first step is to always draw. So I'm drawing my table or my graph of my curve, and I'm going to have negative 1.19. I'm interested to the right of it, so I'm going to shade to the right. Now I remember that my table tells me everything to the left. So now this is when I have to subtract whatever this value is here from 1. So I look at my table, I find a negative 1.19. So I go over here to negative 1.19, negative 1.1, and then, oh sorry, you can't see that. Negative 1.1, and then I go to 9, and I get 0.1170. So now that's great. That's the area under the curve if I was looking to the left, but I'm looking to the right. So now I'm going to have to take that and subtract it from 1. So all I'm going to do is 1 minus 0.1170, and I get 0.8830, and I put that into a decimal, and there's my answer. So we just have to remember to the right, we have to subtract 1. Now our next example is one of the betweens. So our area is between z equaling 1.68 and z equaling negative 1.37. So again, I'm going to draw my table. So when I draw this out, I have negative 1.37 and 1.68, and I'm shading in between because I'm interested in the area in between those two z values. So again, from the procedure table, when I'm looking for between, I find these two values and then I subtract. So I look at my table for negative 1.37, negative 1.3, and then 7 is over here at 0.853. And I don't think you could see that, sorry. And then I look for 1.68, and 1.68 is over here. And I'm at 0.9535. Oh, sorry, you can't see that. So then I write those two down. The negative 1.37 was 0.0853. 1.68 was 0.09535. And I subtract them. Maybe I wrote that wrong. Let's check that. 1.68 is actually 0.9535. I wrote an extra 0 here. I corrected it here though. And so now I'm just going to subtract 0.9535 minus 0.85 0.0853 equals 0.8682, and then I make that into a percentage. So that's as easy as it gets. So you only have problems 8 through 16 to do on this. So I would go ahead and go through that. Let me know if you have any questions, and I'm going to go ahead and finish these notes tomorrow because these ones aren't that difficult to do. You just need to get used to using this table in the back. So clearly, if we would ever have a test on this, I give you that table. I would never expect you to memorize anything like that, so don't get panicky. Just make sure you're able to use that table. Let me know if you have any questions, girls. Hope everything's going okay, and hopefully I can see you soon.